Welcome back to the second lecture of machine learning. Let's just quickly recap what we did yesterday. So yesterday, after a brief introduction to machine learning, we started to talk about linear regression. Linear regression was probably nothing new to you, but it was good to revise firstly the standard formulations through least squares, as well as the formulations through maximum likelihood estimation, which potentially was something new to some of you. Then following, we also talked about the bias variance trade-off, which is a very important concept throughout any of the machine learning techniques we will be discussing in the rest of the course. So yesterday, everything was about regression, which is when we want to make predictions of a function which has continuous output variables or continuous labels. Today, we want to talk about classification. Classification deals with a case where the output variables or labels are discrete. It could be something like 0 and 1, false and true. Does the patient have cancer or no cancer? Is this email a spam or no spam? In general, it can also be a multi-class classification. You can classify digits being 0, 1, 2, 3. But in general, you can always formulate a multi-class classification as a two-class classification. You could, for example, say, is this digit 1 or not 1, or is it 2 or not 2? And then you can rank those classifications by the highest probability. So generally speaking, we can always reduce a multi-class classification to a two-class classification. Therefore, in this lecture, we will only focus on two-class classification. And we start by discussing logistic regression, which is a straightforward extension of linear regression and is the most common technique for building a linear model for classification, which has two classes. Then we also discuss discriminant analysis, in particular linear discriminant analysis and quadratic discriminant analysis, which are other techniques for classification, which the first has also a linear classification boundary, exactly as logistic regression, while the second one gives actually a nonlinear or a quadratic decision boundary, as the name says. So let's get started.